Margaret,
Hello.
take it away.
Okay, so I'm going to, let's just skip ahead. Go ahead, next slide, please. Okay, here's our quick agenda, and there's a screenshot of the model over there on the side. Basically, we're going to give you a quick recap because we've been working on this project for a couple of years now. Status of where we are in converting, in actually using this model, and then a description of how the R tools that Colin is working on to actually build data sets, convert data sets into this, and then a discussion of what we've learned about the data sets with using the data sets we've used so far. So I'll start, and I'm going to turn it over to Colin, and then we'll probably kind of tag team toward the end. But okay, go ahead to the next screen. So our goal, recap one more. So our goal, I have to make the, oh, here we got to make you people go away here. There. Okay. So what we're looking for, basically what happens in synthesis, anytime that raw data, the data are reused in synthesis, is a working group or a scientist will take raw data and reformat it, try to understand it, and end up with something that's derived. What we're looking for is a intermediate model where we can convert raw data to this predefined model and streamline the process of making these level 2 derived products. So when I use the terms level 1, level 2, level 0, I'm talking about either the raw data, this intermediate, or what a synthesis group actually needs in order to answer some questions, really specific questions. Now, if you have this ideal synthesis workflow where raw data are converted into some kind of a predefined model first, then it's much simpler to create sort of generic code that can use that model and manipulate it for further use. Now, with community survey data, we did find some existing models out there. One of them that some folks out there might be familiar with is what GBIF uses. It's called Darwin Core. They have good features, and sometimes they don't cover everything we need, so that's why we came up with something of our own. But we had all these other efforts in mind as we did this. Go ahead, next slide, Colin. This is just a reminder of why you might want to do this, because if you have a harmonized format, you can start to make harmonized plots. And this is an example of one that one of the synthesis working groups working on LTER data put together, where she was able to do this kind of a plot for every data set that they were interested in. For screening, for examining them before you actually decided if you're going to be able to use them. But until they were harmonized, it's really difficult to do these. And this is the sort of useful product that actually a repository could create from a harmonized model as well. Next slide. Here's a little bit of background. These are the models that we examined before we started on this project. We can come back to this if you like. Skip ahead. And the other advantage of using repository like Pasta is that we can also track the source or track the source and final output of any of these conversion scripts. You can say that this data set from the Maria coral reef was used to create this data set for EDI, which is the harmonized one. Next slide. Okay, now we're going to talk a little bit about the data sets we've converted already. So go ahead to the next slide. And this is just a summary. So one of the things that we do in this model is that we actually look at the data values themselves and create some summary metrics. And these are really useful if you want to peruse a big batch of data sets and decide which ones are useful to you. So the summary table that goes with every data set has this kind of information. So far we've already converted 28 data sets, and among those 28 you can see that the temporal coverage ranges from 4 to 38 years. And we do have this a measurement of evenness that we're trying to get an idea of, say, how frequently among those sampled years were, or how frequent was the distribution of sampling among those years. The geographic coverage can vary quite a bit, as you see. Oh, one thing I should say, which I forgot. NEON actually also was using this model to export their own community survey data. And so we have one NEON data set that actually, I believe, has continental coverage, so that's why it has they're not even specifying what it is. But I took it out of the general analyses because it is so high. All the numbers were so high, it was all skewing to the high end. The other thing that's very interesting in these is that taxonomic coverage is either going to be as species or taxa species binomials or in OTU. And so when I looked at the taxonomic coverage, I pulled out the one data set that was covered only with OTUs because, again, the number was so high. We can come back to this if you'd like to know more about or pick into the data, actually the analyses of the data sets a little more often. Next slide. I think we're getting into the, yes. Okay, so now I'm going to just switch it over to Colin and mute myself. Go ahead, Colin.
All right, great, yeah. So I'm going to talk a little bit about some of the tools that we have to help create the model from the L0 data set. And it's getting easier and easier. You know, it used to take me, I think, maybe 3 days, and it depends on the complexity of the L0 data set, but it'd take maybe about 3 days for like a really complex data set to convert it into the model. But with more experience with the model and these ecological community data, as well as having some of these tools in my pocket, I can now create these, convert a complex data set in about a day, or maybe even a little bit less than that. So what I'll be talking about here briefly is that first step, converting the level 0 to the level 1. And since each of these data sets that we have in our repository that we're doing conversions of vary in format and content, it really calls for a custom code or a custom script to do that conversion. And I'm just going to do a quick walk through our GitHub space and show you what sort of documentation we have and where the tools reside. So this ecocomDP GitHub is in the EDI org GitHub space. And here we have the high-level information on the model. Scroll down a little bit, we get down into the documentation, and here we are, instructions for creating, validating, and archiving ecocomDP tables. So we have an overview of what the process looks like, and it basically consists of creating that custom code to do the conversion, running a validation check on those Ecocom tables to ensure things like referential integrity and required columns and tables are present, and then calling on a make EML function to easily create the EML for this derived data product. And then a little bit about archiving, discovering, and reusing these types of data. But I'm just really going to talk about the creation process here. So we have, the first thing you want to do is you want to familiarize yourself with the Ecocom model and ensure you understand where content goes in it, so you can then begin to map that content over to the model and begin that scripting process. So, we have linked to the table descriptions, contents, and relationships. There's the kind of that model, the Ecocom tables and the relations between the different fields that Margaret showed earlier. And there's an authoritative set of descriptions, relationships, and requirements here in this document. It gets into a little bit more detail as to things like say what the column name is, the type that's expected for that column, whether it's null required and reference columns and so forth. So once you've familiarized yourself with that, you could begin to map content over and begin that scripting process. And what we're striving for here is to write a script that reads in the L0 data from the repository, reads in the metadata and the data, and then reformats that L0 to the Ecocom tables while only requiring 3 arguments. So a path to where the output table should be written to, the parent package ID, and the child package ID. And the reason that we want to create a conversion script that only requires these arguments is that later on, when maintenance and revisioning of these Ecocom packages need to be done, we can begin to implement an automated workflow to keep these things up to date. So that's kind of what the ideal is. You know, it's not required, but that's what we're really kind of pushing for. And now the functions available to help create the tables. There's 3 R libraries that help with this process. We have a few in the ecocomDP R library, and those are to basically populate most of the content of the location table. You do that with make location. For the variable mapping table with make variable mapping, and make dataset summary with make dataset summary. And the reason that we don't have more canned functions for populating these tables is, again, that the L0 data varies so widely that it really makes that difficult. But we, I should also note that we've just got online now some resources for linking variables to external ontologies. So we have a little resource here about using Darwin Core or the ecosystem ontology, and this comB resource that allows you to search for ontologies that you may find useful. And here we have some example usage of how to enter that information into that variable mapping table. The taxonomy cleaner R library helps with taxonomic data, and the primary functions that I've used in my Ecocom conversions are resolving scientific and common names to authority systems. So you can point these functions to a list of taxa, as well as a set of authorities that you want to try and resolve these taxa to, and it'll automatically go and try and make matches. And if so, then and if it succeeds, then it updates that taxon table, and if not, then it just lists an NA. But those functions help with the taxonomic portion of the Ecocom model. And then in the data cleaner R library, there are some functions in there for helping to format your date times into ISO 8601 standard. And we have one that does the conversion and it converts the characters. We have one that detects the format string that's being used, as well as reading those ISO 8601 compliant character strings into R to perform operations on. So we have an example script that kind of shows, you know, what we're striving for here in the GitHub space. Again, just relying on the path, the parent package ID, and child. And so this is an example conversion script for BNZ 501 data set, converting and writing those tables to file. And then after you've created your files, you're going to want to do a validation check. And so there's a validate function, validate ecocomDP function in the Ecocom library. And this, again, it does normalization tests, checks for required tables, fields, classes, datetime formats, and all that. And so this validation just ensures that the downstream processes aren't going to break when you go look for a bunch of these Ecocom data sets and you want to aggregate them together, that you don't encounter issues at that point. And then the documentation process, creating the EML for the Ecocom tables, is really easy. There's a handful of arguments that you need to supply to the function. The function's available in the Ecocom library, and it then goes and pulls in the parent EML, takes the boilerplate EML for the Ecocom model and kind of merges the two and creates a rich metadata record for that Ecocom data set. And then the archive process, I think many of you are familiar with that. There's different ways you can get the data into the EDI data repository. And we have methods right now for discovery and reuse, but that's something we're going to save that for another time. Or if any of you have questions at the end, we can chat about that. So let's see. Let me go back to the presentation. So that's where the utility scripts are to help with that process and some of the documentation and supporting materials. Now, maintenance of these Ecocom data packages. I'm going to talk a little bit about that now. This is a proposed method of keeping these things up. This is something that I'm beginning to implement right now. I've been testing. And so you have your user over here that updates an LTER data package in the PASTA repository. I use event notifications an event notification to be sent to ecocomDP EDI repository.org, a server space, which then, so it receives that event notification, and then it goes back to PASTA, and it says, okay, give me that most recent data package as well as the previous version, and return the EML and the data tables. Then a comparison is made to see if the data package, if the data entities have changed in format or in ways in which the conversion script is going to may break, and if any substantial changes have been made, then those are written to the log file, and it kind of errors out at that point, and then the maintainer goes and ameliorates the situation. But if everything works fine, the entities are pretty much the same as they were before. The server then goes out to PASTA, and it pulls in the most recent version of that Ecocom data set and returns the script that did that processing. The server space then executes that script, but for the new L0 data package, and it updates that Ecocom version, does a validation check, creates the EML, and then uploads that to PASTA. So that's a kind of a proposed workflow for managing these derived data sets, and we could talk more about other options during the discussion today. So I think with that, I'm going to hand it back over to Margaret to talk a little bit about some of the lessons that we've learned in this process.
Okay, thank you. Yeah, actually, the idea of running a workflow on a level 0 data set and actually getting all the way through to a derived product is, at least in my mind, it's sort of the holy grail. And since a lot of what we deal with are time series, it would be great if we could demonstrate how to do that. Go on to the next slide. So one of the things that I'm gonna go to now is basically some details. One of the things that we've discovered in the data sets that we've been trying to convert, and which features of data sets, these are level 0 data sets, which features work well, which not so much. If any of you have examples in here, I hope I put them in. I tried to use data sets that I was responsible for both bad and not so great examples, but apologies if any of you have examples for any of these features or other things that have come up that you suspect might be issues that haven't yet. Go ahead and let us know. I think I've got about 5 or 6 slides here with different kinds of features of data sets, and there are probably more. At the end, what I'm going to ask you is, what do you think is the best way for us to communicate this kind of information to you folks, especially you who are data providers, because these are important features, and they mean your data is either usable or maybe not so much. So for each of these, I've kind of come up with a feature, said what it is we need to happen, and then try to come up with an example for what's the best, what's okay in that probably the information's there, but there needs to be some processing, and what simply does not work. So first of all is locations. Most of these data sets have locations. Ideally, they're digital lats and longs, and they're in the tuples themselves. So there's an example of one that is arranged that way. What's the second best is that there are lats and longs for the sites, but they're actually in the metadata, and that's okay. It needs processing, but it's a little more work, but it can be done. In some cases, you might have degrees. Instead of having digital lats and longs, you might have degrees, minutes, and seconds. So there's strings. So it's a parsing and processing. There also could be locations in a second table. So those are all things that we find that work, but they take a little extra effort. What isn't useful really at all are site codes that have no lat and long at all. A place name might be able to be resolved to a lat long someday, but ideally we get that from the original data. Okay, go to the next slide. Related to locations is this concept of site nesting. Over on the right, oops, I have to get the people out of the way here to see it. There's a snapshot of the location table, and what we want to be able to do is, this is a self-referencing table, and we want to be able to detect the parent-child relationships between sites. So understand when one site is within another site. And in some cases, that's clear in the data itself. In some cases, it's really hard to figure out. So I don't even have examples for what doesn't work very well. Next slide. Taxa. So most data sets that are about ecological communities have taxa in them. Ideally, you have already chosen the authority that you use for taxa at an LTER site or wherever your project is, and you've put those codes in. If you haven't, the next best thing would be species binomials, because we can look them up. We may not know the best authority, but we can certainly look them up if there's a taxon ID. So there's an example of one that just has binomials. What really isn't usable at all is local codes, because those are extremely, almost impossible to dereference. And I use the same example because this data set, this SPC 17, if they hadn't included the species binomials and only had this column called species code, it would have been an unusable data set. Next slide. The variables themselves. Now, what we want to be able to do here is actually understand that we've got the right variable with a, let me grab a note here. There it is. We have the right variable, and it goes with the right metadata. Now, the way that this works with EML is that it's simply done by the position of the metadata node and the column number. That's a little bit dodgy, because really what would be nice to have is a key, and the metadata attribute name could be that key. But in some cases, they simply don't match up. So ideally, the attribute name exactly matches the column header. In some cases, we can match them by manual examination. Maybe the only difference is capitalization, or there's a couple of extra characters in the original that are not in the EML metadata. What really doesn't work is no header at all, because then we're relying simply on position and typing. Now, one thing I haven't talked about yet is some of these features can actually be checked. And currently, when the data set is submitted to PASTA, there are some checks run on the column typing and the number of columns in a data set to metadata. There's also a display of the attribute names that are in the metadata and plus the column headers in the CSV. But it's really just it's what we classify it as an information check. So you can look at it, but it doesn't make any decisions about the data set based on that value. Possibly we could consider a different kind of check for certain kinds of data sets. Go ahead, next slide. The date times. We've noticed some interesting date times. Ideally, there's a consistent date time format throughout all the values in a data set. And again, here's an example of one that's consistent. In some cases, and this is methods just change over time, we really don't have a lot of control over that sometimes. But if the sampling regime has changed to the point where, say you collected data only once a year without specifying what the date was, and then later on they started collecting the entire date, the typing of that column is going to change over time, and that could be a problem. What really isn't usable is date and times that are not typed as EML as date times at all in the metadata. This is an example of a really old data set where they actually crammed in some rainfall chemistry into stream chemistry. We fished that out at this point, but that's what it looked like when the data came in as a spreadsheet. Now there are date time checks for EML now, and let me see. There's really not, since most of these, if you don't type the column as a date time, that check can't be run. So ideally, that's what you're doing with incoming data, so that we can actually trap this situation. Which this data set isn't actually in PASTA, and it's now been cleaned up. So next slide. So since we were talking about, for instance, like sites or taxa, there is a possibility that the data that you want to be able to use in the Ecocom model exists in more than one table. And if that's the case, we need to be able to figure out what the linkages are between those tables. Ideally, there's an EML constraint there. That is a feature of a node of EML that's not used very often, but sometimes it is. It would be great if people can put that in, because then we can go look and see specifically what the foreign key linkages are between tables. It is also possible to detect these manually. Of course, this takes extra processing, and I didn't include any examples of these. We also have seen situations where it looks like there's a foreign key, but there's absolutely no integrity at all between the references. Now, again, those are some possible new checks for incoming, which maybe could say, is there a constraint here? And if there is a constraint, does it conform to what would be expected for a database? I think there's only one more. Oh, yes, questions for you. And I think I mentioned these already. And this has to do with anything that Colin and I have talked about. Since we are starting to come up with all these ways to describe usability, what is the best way to communicate these? Do you have comments, or do you think we're just dead wrong on some of these? Also, as far as maintenance, what are your preferences? Would you rather keep your, if you have scripts that can do processing of a level 0 to a level 1, would you rather keep that locally? Do you think that's something that EDI should run for you? And I believe that is about where, oh, one more slide. There are some things missing that you've probably seen. There are still very few robust measurement vocabularies. We are working on some of those with the NCS group, but we will need more help, and we will probably need input from people like you. We also don't know all the right taxonomic authorities. There's probably more out there than we are aware of. I do have later on a list of the ones we've seen people use so far, or the ones we've been able to use and access the APIs for. I believe, I keep seeing one more slide. Oh, yeah, there is on the next slide is just a list of the taxonomic authorities that we've got. But I think we can stop there and ask for questions or discussion or whatever you all think of. Colin, if you want to turn the slides off for now, do we want, so we can see people? Is that?
Yeah, sure, I'll do that. Okay, how about, looks like it's off, okay.
Comments, questions?
Everyone's sleeping.
Please feel free to enter your questions into the chat window.
Yeah.
Oh, okay.
Come out with them, however you want.
So one thing, actually, can I just make one quick introduction here? Some of you might not know Stephen Chong. He's an NC's postdoc, and he's actually working on the ecosystem ontology that Colin actually has a function that can pull URIs from that ontology now. if
Almost.
we want to, almost.
Almost.
Okay.
Hi, Stephen. Yeah, welcome.
Hi, Stephen.
Even with LTER ASM, for those of you who are LTER folk.
Kate has a question. For what it's worth, I can use cases for both local and remote scripts to take data from level 0 to level 1.
Yeah, one of the things we were curious about is if anyone in this group would be interested in making their own level 1. Is that something that you see as important to your site, or would you rather, as a lot of these folks are LTER related, or would you rather that EDI took care of that? And I think part of something you need, usually you will get questions. I mean, there's usually, it's difficult to figure out everything we need to know about a data set from the metadata. So usually there'll be some kind of interaction with the site or the data creators. I could call on a few people. Or not.
How about that question Margaret proposed or posed of how these these issues that we find with data sets in that reuse process, how do you think we should best communicate that? Or are some of those issues that were raised, are they really non-issues in your opinion?
So this is Kathy, Kathy Todd Brown. So depending on the study I work with soil biogeochemistry, and if what I'm interested in is, say, predictive variables for organic carbon stocks, I might not actually need the location of the site for certain studies. If I'm just looking for like a correlative scatter for a bulk density and organic carbon or something along those lines, it's a typical curve. But so there, I can see use cases where I don't actually require latlong for the data that I'm interested in. Latlong is certainly more useful, but the data, depending on my study, is still useful without the specific locations there.
Well, that's a good point. I mean, one of the things that we're aiming for here is an intermediate format that's useful for use. Well, that's broadly useful, where we don't necessarily know what the output, what the level 2 question would be. But it does sound like if we were to make these sorts of features requirements, it might impede your use of a data set, because it would mean that, well, it would slow down the conversion, or at worst, we would not convert it at all. But that's something that we would need to be aware of, or we need to, for you as a level 2 user, you might have to go back to the level 0, and we'd probably want a way to connect you to that level 0 more easily if it wasn't going to have a converted version.
Yeah, that makes a lot of sense, Margaret. I think that in general, latlongs are good things to insist upon, but you're orphaning data whenever you insist on specific features in your data set.
And actually, I think in this corpus of converted data sets, there are a few that have no latlong, which actually I found interesting. I'm not sure what to make of that.
Sometimes it's a data privacy issue.
Well, yeah.
So that's
Yes.
one thing that I've run into, is sometimes there's either noise introduced into the latlong coordinates to
Obfuscate.
Yeah. Or it's a rare species and you don't want someone going to that location and disturbing the habitat. or it's agricultural data that's economically valuable. So there are some use cases where you don't actually want the latlong in the data released data set.
Okay.
Dwayne says, if you could choose 1 or 2 new quality checks to add to pasta, given that we stopped or are done talking about the latlong problem. So to add to pasta to help this processing go better, what would they be?
So I'm going to kick that one over to Colin. If there was something that would make it go faster, what would it be?
You know, I think the date time format check that you all implemented, I think early last year, is great. You know, as the community becomes used to that check, and as methods for being able to correct those date time issues become more available, that's going to really help things out. Just having that congruence between the date time character strings that are listed in the data set and what the actual format is will help tremendously. I think, you know, the congruence between column names of a table and attributes in the EML is a big one, because I think that that's an important one, because in my workflow for extracting definitions and unit types and so forth for each attribute that's in that L0 data set and gets ported over to the L1, being able to programmatically look up what those definitions are is pretty fantastic. And, you know, granted, I've only run into, you know, a couple instances of where that congruence doesn't exist, but so maybe it's not as high of a priority, but I think that's definitely important, because there's a lot of information that you can pull out of that EML record if you know what the attribute name actually is. So those are 2 that come to mind. I don't know, does anybody else out there have anything? See, Wade's unmuted. Maybe he wants to.
I was going to chime in on a more semantic thing for Margaret, but
okay.
Yeah, I can't think of anything specifically related to, other than, you know, standard congruency type checks, just to make sure that things actually line up the way they should. I mean, the one, I think, weakness of EML is that it doesn't have the support for kind of like semantic information. If you're talking about a multi-entity data set, other than constraint, you know, which I agree with Margaret, I think has been underutilized. There's not much of a way to describe relationships among or between attributes for things, you know, for things like qualifier codes. That's something that comes up a lot. Things that are sitting in data that would be maybe hard to port over, or mistreated as measured attributes when they're actually essentially metadata. Then, you know, that's a long-standing issue with EML, but that's not something we can address with a congruency check.
So you want to just slide right into semantics here?
Actually, my point backed up a little bit more about the suitability of this model and the target data sets. I know this started with a working group that was interested in doing these taxonomic surveys, but one issue we end up with a lot of problems with and figuring out how to map our data to these kind of models is that the essential design of the research study is specialized in some way that could lead to misinterpretation if this was represented as a taxonomic survey data set. For example, it's like a nested design where they've chosen, you know, a stratified design where they've chosen half a dozen key species to monitor and just track those, and we have everything there. But if this were used by someone in a synthesis group as a representation of species richness or something, it would be biased. And we have like at least 3 different kinds of taxonomic survey studies that people routinely do, and some of them are true surveys let's measure everything in the quadrats along these, certain paths, and we have lats and longs and dates, and those I think would be good candidates. But then a lot of these are, let's just pick, the dominant, flowering plants out of these, pots and just reference them. So they're good for temporal comparisons across years and biomass production for those taxonomic groups. But just to throw all those into the ecocomDP model and then make them available for use for those kind of studies that you were showcasing early on, like that plot, would be problematic. And I just wondered if your group had discussed, essentially how to either communicate the information or how to self-select what data are distributed in this model.
So there's a couple things that have come up, and so one, which is the complexity of the level 0 data set. Our original goal was that there would be a place in this model for everything in a level 0 data set. That's actually not possible for every one we found.
But we do pretty darn good.
We do, well, depending on it, and for some, depending how these level zeros are put together, it is more or less difficult. And the more complex the original, I think we had one example where the data set actually has the entire experiment in one data set, and it includes soil parameters, stream inputs and flows in chemistry, and some community survey information. And our decision then was to try to decide which of those things we can handle here. Corinne has her hand up. Go ahead.
I think that wasn't the question that Wade had. So
Well,
I think we talked about this problem of not serving all species that are occurring in one place. And the working group suggested that a very good way to judge this is to actually document the number of taxa that are in this data set. And so that is one of the what we consider the metadata. So there's one table in there that has some metadata, I don't know what you want to call it, but that is one of them. So the other one is, that was very important to them, was the time range, and then how many samplings and how evenly distributed the sampling times were. So those were the two things that we thought can be automatically generated without any judgment by a data manager, without any taxonomic knowledge. We can say this data set has only 3 taxa, and then somebody who wants to work with them will have to judge and say, oh, if there are only 3 species, then it's probably not a real survey. Then it's probably just what you described, Wade, the main ones or the ones that were of interest. So I've just converted one of ours, which was only crayfish, and it was only the native species and the invasive species, and that was of interest. And so anybody who sees that will see that this data set has like 2 species in there. Which,
and if you go back to let's see, on the summary metrics table, you would see the minimum taxonomic coverage is 1. So there is a data set in there that has 1 taxa. But actually, Wade had 2 questions. One had to do with the complexity of the data set, level 0 data set. And yes, we have seen some that are so complex that we cannot put all the information that's there into this model. And for those, the general feeling is that we do what we can, but we want to make sure that the level 1 metadata makes that clear. And for right now, most of the metadata that we're getting, that we're putting into the level 1 EML, is actually being generated out of the level 0. And so these conversion decisions that we made need to be added as well. And I think, Colin, didn't we decide we should put them in a paragraph and they're the second part of the abstract? That there was a special section of the abstract where we actually talk about the choices that we had to make.
Yeah, we're thinking about how to implement that. Yeah.
Yeah, it sounds like a good plan generally, right?
Yeah, they need to be up front.
Some narrative.
And one of the other things that the working groups asked was, they do want to know the difference between a level 0 survey that has, say, what you call an open species list or a closed species list. We only count 10 things, or in our case, we count 150. But That's a major difference between the way surveys are run. And even with the number of taxa, which is something that was straightforward to generate from the summary, it doesn't tell you whether that 52 taxa is a closed or open species list. So there's probably a set of terms, some additional keywords or metadata terms that we could be adding that may or may not be able to be gleaned from the level 0 metadata easily. And that would be one of them.
Right, that might be another case for a future iteration of the model, where there might actually be a table with some control vocabulary terms that could be, research loaded for exactly that, closed taxonomy, open taxonomy, just basically some flags, essentially structural tags that could be queried as a table.
Yeah, and we haven't actually, the mappings, I believe, we would have pulled the variable mappings. All of the main observation tables have an ancillary table that includes mappings to them, so that you could map any of the variables to some external vocabulary. Now, these are all data-related values or data-related columns, not metadata. So if you being able to understand that the taxa was from a closed list, that might have to be somewhere else, and I think that's what. Yeah, but I agree with you. We need additional terms that would be of value to people doing discovery or trying to ascertain whether this is the right data set for them.
Yeah, I mean, it could be kludged initially with keyword sets, but I think, maybe a more structural response later would be good to consider.
Yes, but I think we ended up discarding that because we as information manager, and certainly if EDI does any of this, would not be able to judge this kind of keyword. So unless it is explicit in the methods of the L0, we would not be able to assign that flag. And I don't think we should.
So that brings up another issue, though. Do you feel, as data managers or stewards of level 0, that we should be getting your? I mean, do you want any? Would you like to be involved in the review process? Would you like to see these data sets before they go out? And then the conversation gets even more complicated after that. And I think in an ideal world, this is a collaborative process, generating these intermediate harmonized versions of a raw data set. And the same way you look over data sets before you push them into PASTA to begin with, probably someone who understands the data, ideally that person should look at these as well. But at this point, we don't have a process identified for that kind of an interaction.
Well, we kind of know, what that process would look like. And there have been instances when I'm doing these conversions in which I do make contact with the IM, or say the data provider, just for clarification on something or for some additional information. But that is, time consuming on the part of the person that the query is being sent to. And yeah, do you want to be a part of that process? And
so those of us, and Corinna, maybe this is a question for you. As you've done this conversion for data sets you know well and for data sets you don't know well. Do you have a feeling for your confidence at handling both kinds?
I was actually just thinking about it, that there is another check that I don't know how far that has moved up in the list of quality checks. What I've come across is that metadata did not describe the columns properly. So column names had changed, not the number of columns, but the column names had changed in the data set, and the metadata were different. And the code definition descriptions for a code list had changed. So there were more codes than were actually described in the EML. So if those things could be checked, that would make the conversion from L0 to L1 somewhat easier. I mean, those were things that I had to ask from the person from whom I tried to, the data manager from whose side I tried to convert data, because, well, they just weren't in there. So those would be the two checks that would really help. I think they would help a lot of data.
So no one jumped up and said, it'd be great to make some of these out of my own data sets. Is that wishful thinking? That you'd consider as a data manager being able to create these, do these conversions yourself? And in lots of cases, if we've got to start on the script already. We just give you the script because it's in the level one. Level one data sets all have the script, their conversion script inside. But yeah, I'm curious if any of you would be interested in running these conversions yourself with our help, with EDI's help.
Yeah, or corollary would be, what would it take? You know, do we need to demonstrate the value of these types of data in these data models that we're creating before you see it really worth your while? Is it something that, yeah, you need to demonstrate the value first, or what would it take?
So this is Kathy, and I essentially go from a level 0 to a different data model for level 1 for the projects where I run informatics support already. So this type of pipeline is something that I do in my own research. And going to an EDI data model is something I would certainly be happy to entertain and plan to look a little bit more closely at. So if that is a yes to your question there. Yeah, and the issue is that a lot of the level 0 data sets in my work are already published. So I feel to preserve the integrity, registering another data product. I don't know. I was planning on just pushing the scripts that would then process the already published data. So that starts becoming a semantic question, or not a semantic question, but just an intellectual decision on, are you saving the scripts or are you saving the data products?
And actually, we're saving both.
Yeah.
At this point. I think the main reason is that it's more straightforward and data sets are relatively easy to discover, whereas scripts are more difficult.
So I think one of the things that I'm noticing is that the data structure that you're developing for level 1 is designed to be more generalized and generic, whereas for my specific projects, they're a lot tighter and smaller. So just a question. Go ahead.
So yeah, so yes, that is generally true. Although they're all data about community surveys, and that is, I think, a little bit different. Your domain is soil biogeochemistry generally, right? I mean, you may have in organisms in the soil, but
although there is for one of the projects, there are plant community surveys that I'm working with as well.
Yeah, and we started from, in fact, at the first working group, or the workshop that we held, we had members of a couple different synthesis working groups, people who had worked on the Popular database, which was a community survey model for a large LTER-wide project. And all of us had some familiarity with Darwin Core. Which is really good at handling some kinds of occurrence data, but not all. But most of these groups had not actually considered using it for their own. So we're kind of putting that in the level 2 group, that could be something you could make out of this format pretty simply. So I forget did you have a question, or was I sort of got off topic? I'm sorry. The idea, my point was that this isn't intended to be a model for any kind of data. In fact, when we first started, we were thinking about it in terms of population data as well, but we actually reduced the scope really fast, because population data is much more about the traits of those populations, and it didn't fit. So we decided, well, we're going to keep the scope actually rather narrow and really only look at abundance, densities, those kinds of measurements instead. But the same pattern could actually possibly work for other kinds of data. That would be someplace else we should go, or could go.
Our time is almost up. Are there any other questions for Colin and Margaret?
One last question. Is there, I haven't studied the schema well enough yet, and I've missed one, or at least one of the other presentations. Is there a way to identify packages in EDI as utilizing this model? Is there a way to distinguish those? Because I figured that would be covered in the document.
Yes, there's a key. They have a keyword. It's the name of the model. So if you search
ecocomDP,
you should get 20. I think there's 28 right now.
Okay, good.
Now, one caveat: we have tweaked it a little bit. So some of the early ones, the models are slightly different. But don't let that stop you at this point. Please.
Yeah.
We've got to go back and kind of reharmonize.
Yeah, it's relatively high on my priorities these days.
You can take them all, run them through the validate script, I think, and see what we tweaked. But
yes. So on the front page there, under data, there is the how you would find it in the data repository, in EDI's data repository, these models. Another option, if you're in the R environment and you have the Ecocom package there, you can view all the available Ecocom, and that also includes Neon data products. It will include Neon data products because those come online. And then there's actually about 50 data sets from the Poplar database that we have a generalized script to convert into this model, and that is also listed there on the front page of the GitHub.
One of the tasks that's actually been interesting is identifying data sets that are good candidates for this. If you because I'm related to a site, I can say, oh yeah, it's those 5. But actually, they have one more that they just started making recently that is already more. It's a kind of a combination of all the originals with biomass added. And so, if I was looking now, I wouldn't even use the original 4. I would use just that one, just the biomass data set, because it includes everything else. But that's actually an interesting problem. We have a processing queue I'm not even sure how long it is now. It might be up to around 100 data sets that we think are candidates, but that kind of a screening process has to go on for each one we tackle. And maybe that's enough for now.
2 o'clock Central Time.
Yeah.
It is. We are at the 00.
I'd just like to mention that Mark put the link into the chat window for the search results, if you search for ecocomDP and so on. So if you want to look at this, you can follow this link.
I would still like to know why people signed on to this session. What did you get out of this discussion? What you were expecting, Jason, Adam?
Yeah, I was just kind of curious to see what was going with it. I wasn't sure how I was necessarily gonna immediately implement it here, but not sure.
Well, Jason, we did convert a handful of Bonanza Creek data sets, so be interesting to see what you think of them. If you'd say these are completely unrecognizable, or not.
Yeah. But thanks for your interest. Yeah, I'd be happy to work with you on this.
So as far as the important features, I will probably go with the same kind of good practice sort of documents that EDI and LTER have used before. Although there may be an advantage to some other format, or I'm not sure, or taking into consideration the kinds of comments that Kathy had. It's like, just because you want to see latlong doesn't mean it's necessary. So.
And Adam, what brought you here?
His mic's not working, so he's typing in the chat window. But but while he's typing, yeah. So we do collect on an annual basis for a long time series of a lot of like plant and invertebrate population studies data sets that we collect them in a few distinct, vegetative zones and flooding zones across our site for kind of a monitoring study of trends and population studies. And so my interest is just in looking at the model and seeing which of those would be good candidates to potentially contribute in this format. And that does get at the crux of the question I was asking about the the fact that some of these are not actual unbounded species list surveys, that they are just targeting a lot of the top flowering plants and things, in these quadrat studies, but in some cases, like our mollusk studies, they do measure everything. So I think it's just, as long as there's as long as there was the knowledge that, different research methodologies would potentially be stored in the same format, I think, that's fine. We'd consider contributing those, in this way.
Great. Yeah. So I think if you know this, then having a sentence about this in the method somewhere probably would help a lot.
And that is in our methods. They do describe that these are, just sub-sampling a subset of what's there and all that. It's in the methods already. But yeah.
So I think we all have to keep in mind that this is still such a low-level product that you do need to have a fair amount of understanding of the methods that are being, and somebody who wants to use these data still has to read the methods. If you just download and use it for something, that's just not going to fly, period.
Right. Yeah, that's just poor due diligence. Yeah.
Yeah, and I think we will have to make that pretty clear, because, well, as we said in the outset, we're not making any decisions. We're just trying to convert what's there.